Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue with our book of corrosion, and this is the chapter 2. We are going to start with the episode number 3. In this episode, we are going to cover carbon steels, the designation of the steels according with SAE, the stainless steel. What is the meaning of stainless steel? The series 18A and 1810 of stainless steel, and the famous series 300 used in marine environments. This is a great episode because in this episode we are going to analyze stainless steels applied for marine environment for fabrication of marine elements in your boat. Okay, we are going to start with the designation of the steels. Carbon steels. Okay, 90% of the world have a production of steel. For that reason, it's the cheapest alloy on the environment in comparison with other non-ferrous alloys, more expensive. High carbon steels, they have around 0.5% of carbon in percentage. 0.5, the high carbon steels. The medium carbons, they are in between 0.2 and 0.49 in percentage of carbon. And the low carbons are in between 0.05 and 0.19%. For that reason, a stainless steel marine grade is considered low carbon steel because it's around 0.05% in percentage of carbon. Okay, those are the amounts of carbon in each group of those steels, carbon steels. Alright, steel designation. My friend, I want that you follow me in this part of this episode slow. If it's necessary, you can repeat the episode in order to learn the procedure in order to learn how is the procedure to identify the steels and stainless steels, of course. What is the nomenclature used in those specifications? Okay, this one, the specification of the steel is according with SAE, is the Society of Automotive Engineers, and also with AISI, is the American Iron Steel Institute. Both of them regulate the designation of steels. Both of them, they have the following specification. They use 4 digits. 4 digits in the designation of the steels. And this is the meaning of each digit in those 4 digits. Okay, the first digit indicate the first component in the alloy. The first digit indicates the first component in the alloy. What is the meaning of that? If the first digit is 1, it's because the first component is carbon. If the first digit is 2, it's because the first component is nickel. If the first digit is 3, it's because the first component in the alloy is nickel chromium. It's nickel. We mix it with chromium. If the first digit is 4, it's because the main component in the alloy is molybdenum, with 4 at the first one. If the first one is 5, it's because the first alloy is chromium. With number 6 is chromium with vanadium. With 7 in the first digit is tungsten with chromium. If the first digit is 9, is silica and manganesium. This is the first digit. The second digit, the second one, okay, this is the main component on the alloy. The second one is the percentage of that element, of that main component on the alloy. is the percentage. And the last two digits is the content of carbon in percentage. Okay? The first digit is this. Those are the first digit. This is the main element in the alloy. For example, the plain carbon steels, they start with the number 1 in the first digit, because the first component is carbon. The second digit indicates the concentration of the major element in percentage. If the second digit is 1, it's because the percentage of the main component is 1%. If the second digit is 5, it's because the percentage of the first component is 5%. And the last two digits of the series indicate the carbon concentrations in hundreds. The carbon concentration in hundreds. For example, we are going to check this alloy. It's 5130. Indicate 51 is number 5, is because it's chromium. How much percentage of chromium in this particular example? Chromium, 1% of chromium, and the last two digits indicate that is 0.30% of carbon. Nice, simple. We are going to repeat. 51, 5 is chromium. 1 is 1% of chromium. And 30 indicates 0.3%, quiz question, of carbon. If the last one is 40, is 0.4% of carbon. Not 40% of carbon, not 30% of carbon, 0.4. Don't forget. Okay, simple. This is the nomenclature, this is the procedure to identify an steel, low carbon content. The first digit is the first element in the alloy, different than iron. If the first element is 1, if the first element is 1, it's because the main component is carbon. If the first element is 3, it's because it's nickel chromium. If the first element is 7, it's because it's tungsten with chromium. Those are the first digits. The second one is the percentage of this element. And the last two digits is the percentage of carbon in hundreds. Simple. That's the designation of steels. Steel is famous because high strength ability. What is the meaning of that? Oh, that steel alloy is 7,000 psi. What is the meaning of that? The yield point is 7,000 psi. Oh, you apply 7,000 psi before the metal break. That's the yield point or fracture point. All right. Other element of measurement is the compression. How much is the compression of that steel? Is 120,000 psi. Okay, that element is deformed permanent after 120,000 psi is deformed. Before of that, if you remove the pressure, the metal returns to the original position. You remember that? It's exactly like this. You remember in our class of intro, this picture? In this picture, if you remember, we have the tensile strength. That's the yield point. This is the maximum strength supported by the metal before the metal is broken. Look at iron. It's 200,000 psi before the metal is broken. Oh, before 200,000 psi is the elastic area. This is the highest in comparison with the rest of the metals. What is the second one with high tensile strength? Nickel. For that reason, the alloys of metals with nickel have excellent tensile strength. You remember nickel? The alloy of the propellers is nickel, bronze, and aluminum, that alloy. That alloy have a tensile strength superior than steel. Yes, the propellers in Nibral, they have superior tensile strength than steel. And what is the metal with less tensile strength? Oh, lead, 10,000. Yeah, lead is malleable. The elastic area of lead is practically nothing. A little deformation and is deformated permanent. Lead is heavy with a lot of neutrons in the nucleus. Lead is good to storage electrons, but it's not good in tensile or torsional strength. That's not good because the yield point, the breaking point is too close. Alright? You like? That picture is very important. That picture is in your book of intro, in the intro to marine class. Alright, my friends, we are going to continue with steels with high strength, with high capacity, high strength. Those steels, they have this nomenclature: AH32, DH32, and the rest of those are steels with high strength. We are going to consider the curve of deformation of a steel. The curve of deformation of a steel is this. This is the deformation, and this is the strength in PSI, the strength applied to the steel. And the curve is like this. And this is the yield point. And this is the ultimate strength. What is the meaning of that? In this area, the deformation of the material is elastic. What is the meaning of that? You apply force until this point, and if you remove the force, the metal returns to the original position. It's elastic. After this point, the deformation is plastic. The deformation after that here is a plastic deformation. In this point is the break point. It's the point when the metal is fractured. In steel, that point here is 200,000 psi. Steel is an iron alloy, have the maximum tensile strength. Iron have the maximum tensile strength in comparison with other metals. You remember that picture? This is the picture that we used in our class of intro. In that picture, we are going to analyze that the iron in the bottom have the maximum tensile strength, 200,000 psi. Oh, what is the meaning of that? You apply 200,000 psi, and in that point, the metal is fractured. Before of that, if you remove, before a little less, 180, if you remove your force, the metal returns to the original position because it's in the elastic area. Alright? This is the meaning of that, and the breaking point is the point where the metal is fractured. Alright? What is the other metal in that table with high tensile strength? It's nickel. Oh, nickel. Nickel is wonderful. For that reason, the alloys with high content of nickel, there are alloys with high tensile strength. Yeah? In ferrous and non-ferrous alloy. You remember a non-ferrous alloy with high content of nickel, famous in marine application? Yes, nibral. Nibral. That alloy is a perfect alloy with high content of nickel. That alloy have a maximum tensile strength superior than iron. Normally, the alloys have superior characteristics that the metal separated. For example, there are alloys, steel alloys, with superior tensile strength than iron. Yes, there are alloys with 230,000 psi of maximum tensile strength. And there are ferrous alloys with maximum tensile strength superior than steel, because it's combination of different metals with high tension strength. For example, nickel is an element with high tension. Titanium, tungsten. What happens if you if you create an alloy with those three metals? You have an alloy with high, ultra high tensile strength. This is the ability of the metallurgical engineers to discover what components in the alloy increase that property or decrease other property. And this series, the series 32, they have the yield strength 45,000 psi, and the ultimate tensile strength around 85,000 psi, the breakpoint. And the series 36, they have the yield point 51,000 psi and the breaking point 71,000, in between 71 and 90,000 psi. Remember, this is the yield point. This is the yield point, the moment where the material passes from the elastic area into the plastic area, the moment where the material passes in between the elastic deformation into the permanent deformation, and this one is the maximum tensile strength. All right? Don't forget that designation. Other important designation in steels is the ABS steels. ABS steels are type of structural steel which are standardized by the American Bureau of Shipping and is used in the construction. I mention only because it's important that you know, but in marine application we don't use those steels, the ABS steels. In those steels, the yield point, the point where the metal passes from the elastic deformation into the plastic deformation, is around in between 30,000 and 34,000 psi. And the maximum strength is in between 58 and 71,000 psi. This is only for information. Those steels, ABS steels, are used in construction of buildings, in construction of in residential application. Okay, now we are going to start talking about stainless steel. Stainless steel is important in our business because it's the preferred steel alloy used for marine application, and especially one series of stainless steel that we are going to talk right now. Remember that stainless steel is a ferrous alloy with a high content of chromium. Look, high content of chromium in between 14 and 18, maximum 26% of chromium, and also with high content of nickel in between 2 and 5% of nickel. Both elements, chromium and nickel, have similar properties. Especially chromium inhibit the corrosive properties of the iron and inhibit the magnetic properties, both of them. And nickel help to inhibit corrosive properties. For that reason, nickel is commonly used in non-ferrous alloys. You remember nibral, you remember monel, you remember aqualoid. Those alloys, they have high content of nickel, because nickel in non-ferrous alloys help to improve the anti-corrosive properties. All right, eliminate the corrosive properties. Nickel in non-ferrous alloys. In ferrous alloys, nickel and chromium eliminate both of them corrosive properties, and additionally chromium eliminate the magnetic properties. Remember, it's important, if you are a marine technician, keep in your pocket a magnet in order to identify if the bolts, if the hardware used for other subcontractors are appropriate in your boat, in your business. The magnet is a good tool, but I have another tip. Check this video.
Like I explained in previous episodes, you can check if an steel is marine grade basically with the magnet. For example, this is a plain steel, it's magnetic. It's a plain steel with high content of carbon. This steel is highly corrosive and is magnetic. This one is a stainless steel with high content of chromium and high content of nickel. This one is not magnetic. One way to verify if the hardware used for subcontractors is appropriate for the marine environment is with the magnet. For that reason, a good engineer have a magnet in your pocket to verify if the hardware used for other contractors is appropriate in your boat. This is with the magnet. But also with the grinder, you can verify if the steel is marine grade. This is a regular steel and this is stainless steel, marine grade. This steel, the regular steel, produces a spark with the grinder. A lot of spark. And this one, the stainless steel, practically nothing. Use a little, of course, because have iron, but it's a little in comparison with this. This is another way to identify if the steel is appropriate for a marine environment.
Yes, the spark. Yes, the spark. A good stainless steel, marine grade, produce practically nothing. A little spark because have iron. Remember, iron is the only metal that produces spark when you pass the iron close to the grinder. The non-ferrous alloys, you can pass to the grinder, no spark. Aluminum, no spark. Copper, no spark. Non-ferrous, no spark. Ferrous alloys, yes. The only one with practically nothing is stainless steel. The pure stainless steel, marine grade especially, zero spark. Not zero. 0.0 something. Alright? But it's practically nothing. This is another indication that that steel is not good. Oh, this is the bracket to install the air condition. Okay. It's marine grade. Oh, of course. This is okay. Can I check with the magnet? It's a little magnetic. That's not good. If it's a little magnetic, it's not good. Will be corroded easily. Let me approximate the grinder. Oh, look, a lot of spark. That's not good. That alloy will be corroded. In 6 months, it's corroded. No, because no, should be marine grade. No magnetic and practically no spark. Don't forget, this is a good tip about the stainless steel. Okay, stainless steel also have other components. You see, carbon, of course, in between 0.2 and 0.4%. Really is less than 0.2. And magnesium, silica, sulfur, it's not too much, but it's 0.05% maximum. Copper in between 2 and 4%. Oh, stainless steel have copper, high content, in between 2 and 4%. Molybdenum, 1%, and neodymium in between 1.5 and 2.5%. Oh, nice. Those are excellent components. This is a special alloy, and in our business is necessary. This is stainless steel. We have a lot of examples where we use stainless steel. This is one of the examples. On the anchor systems. Stainless steel does not corrode, but in high salinity environments is corroded a little. Yeah, it's not completely zero corrosion. No, it's a little corroded, especially depending of the environment, depending of the salinity of the environment is corroded. Okay, stainless steel contain a lot of amount of chromium, and that chromium produce a film over the surface of the alloy. That film is oxide of chromium. That film is oxide of chromium. And that oxide of chromium prevents the corrosion because block the intrusion of oxygen. For that reason, if you eliminate that film, the stainless steel produces other film. But if you sanded that film periodically, you destroyed that protection and the metal will be corroded. For that reason, a good tip to keep the stainless steel protected from corrosion is keep the stainless steel clean and polished. If the stainless steel is clean, the stainless steel is protected by itself. Right? The enemy is when the water, the stagnant water or the wet surface stay over there for a long period of time, destroy that film of oxide of chromium. Yeah, chromium is added to the steel to increase resistance to oxidation. This resistance increase according with the amount of chromium added, of course. When you added chromium to low alloy steels, the chromium can increase the response to heat treatment. And of course, it's better, it's hard, and it's a strength. Basically, the chromium produces a film over the surface, oxide of chromium, and that oxide of chromium inhibits the intrusion of oxygen in the alloy. What happens when you have a magnesium in the alloy? Magnesium is added to the steel to improve hot working and increase the strength and the hardness on the surface. This is another important component in those alloys. What about nickel? Oh, nickel, magic. Nickel is added in large amounts, around 8%, no more than 8%. And is added at the same time with high content of chromium in stainless steel. Nickel improves resistance to oxidation, resistance to corrosion, increase the hot work, and increase the hardness of the surface. Nickel and chromium have similar abilities to inhibit corrosive properties. What are them? Molybdenum. Molybdenum, when you added molybdenum in nickel steels, improve resistance to pitting corrosion. Pitting corrosion is that corrosion that produces small drills, perforate the material, pitting corrosion. Especially when the metal is exposed to chlorine environments. Chlorine, you remember how catastrophic is chlorine and fluorine? Yes, chlorine perforate the metals. You remember the guys dedicated to the service of pools, they use a lot of chlorine to keep clean the water of the pools. The containers with chlorine destroyed the box of the trucks of those guys. That's not good. Produce pitting corrosion, perforate the metal, perforate the steel of the trucks. Yeah, for that reason, if you manipulate the chlorine, you need a special trucks with the box in a fiberglass or other similar materials. Yes, and the sulfur chemical. You remember I said at the beginning of this program, be careful with the concentration of chlorine, the concentration of sulfur, the concentration of fluorine, the concentration of phosphorus. Those are highly corrosive elements. Highly corrosive. Okay, sulfur, phosphorus, chlorine, and fluorine. All of them. When you added molybdenum to alloy steels, the molybdenum improved the performance to hot work and increased the hardness of the surface. That's used in the fabrication of tools, in the fabrication of blades, cutting tools. Titanium, chirurgical alloy, titanium. For that reason, when you have problems with your bones in the hospital, they repair your bones with pieces of titanium, because the titanium have no interference with your blood, with the acids of your body. It's magic. The steels alloyed with high level of titanium are used in chirurgical situations. The main use of titanium is an alloy element in steel is for carbide stabilization. It combines with carbon or with titanium and minimize the intergranular corrosion. Intergranular corrosion is the corrosion in the boundary around the carbon deposits. That's the corrosion in that area. But if you have high level of titanium, you eliminate that possibility. For that reason, it's used in chirurgical elements because eliminate the intergranular corrosion. Let me explain quickly what is the meaning of intergranular corrosion. I have two pieces of steel and I weld that area. I weld with a proper material, with a proper steel. But in the area, in the neighbor, in between the welding area and the original material in that neighbor is produced oxidation, that one. This is intergranular corrosion. Is the corrosion in the neighbor of the welding area. When you have two dissimilar metals together. In that neighbor is produced intergranular corrosion. If you have titanium in the alloy, the titanium eliminates that possibility of intergranular corrosion in the neighbor. For that reason, it's critical, it's important in chirurgical devices. Phosphorus, hi Bobby, phosphorus. Phosphorus is bad in general, but it's good for other purposes. You remember the bearings used in the turbochargers? The bearings used, you remember the speed of the turbochargers? More than 150,000 RPMs. And those plain bearings with copper and phosphorus resist those speeds and improve the lubrication. Yeah, phosphorus is good in some situations, especially in plain bearings for high speed and high tensile strength. Yeah, it's usually added with sulfur, two catastrophic elements, but both of them together are good in this situation to improve the machinability in low alloy steels. Phosphorus in small amounts improve the strength and improve the corrosion resistance. Phosphorus additions are known to increase the tendency of cracking in welding areas. Yes, it's used in the springs, the spring valves. They have a high level of phosphorus. For that reason, when you take the sample of oil, you need to analyze the content of sulfur. You remember that video? Okay, exactly. And also you can buy the poster for the analysis of the oil. And in that poster you can identify what happens if I have high level of phosphorus in my oil. Okay, this is phosphorus, and now we are going to talk about other special alloys. The alloy 18A and the alloys 1810. So they are stainless steel, great alloys, special for marine environment. The grade of the stainless steel refers to the quality and durability and temperature. The numbers 18.8 or 1810 is the composition of the stainless steel and refer to the amount of chromium and nickel in the product. 1810 is the amount of chromium / nickel. For example, 18A and 1810s, there are the most common grades of stainless steel used for preparation of food. Oh, nice! And dining, and also the 304 series stainless steel, series 300. They are part of those groups, 18A and 1810. For that reason, in some applications, the engineer said, in this element in your boat, we recommend 304 steel, series 300, or 1810. 18% of chromium and 10% of nickel is the content of chromium and nickel. Let me check that. The first number, 18, refers to the amount of chromium, and the second one, the amount of nickel. 18.0 is because have a little amount of nickel, 0.75%. 18-0 is also called 430. That's the stainless steel series 430. It's basically pure chromium and a little amount of nickel. The series 400 are magnetic. They are the only series of stainless steel marine grade with magnetic properties. The series 400. Yeah, because the amount of nickel is practically nothing. The other series, the 18A and 1810, they have high content of nickel, and both of them, nickel and chromium, inhibit corrosive and magnetic properties. Okay, don't forget that. The series 400 is the only marine grade alloy with magnetic properties. In some cases, in some situations, in some designs, you need a good stainless steel, zero corrosive, but with a little magnetic properties. In the fabrication of the plungers for solenoids in marine applications, you need magnetic properties. Okay, that's important. Don't forget that. Those are the series 18A. The first one, 18, is the amount of chromium, and the second one is the amount in percentage of nickel. All right, good. And now we are going to start with the series 304. This is a very common marine grade series. 304 is used for skins, tabletops, coffee, stoves, refrigerators. Yeah, it's very common in hospitals, in restaurants. Very common. The series 316, marine grade, 100% marine grade. Marine grade stainless steel. This is the most famous 316. Is stainless steel with a high content of molybdenum inside. Of course, have chromium, nickel, and molybdenum. Okay, is the preferred stainless steel used in marine environments because inhibit the pitting corrosion, the corrosion that perforates the metal, pitting corrosion. It's better than other type of steels. The type 316 is also used in chirurgical implants. Yeah, exactly the same. You remember with titanium? This one, the 316, is used in medals for fractures. Is the series 316. This is, don't forget that. You remember this intergranular corrosion? This is the picture that I showed before about the corrosion produced in the neighbor, in that area, close in between the welding area and the original material. Yeah, it's especially during the welding of a stainless steel, the carbon and the chromium react and produce that area exposed to oxidation. Yeah, all right. And those are specialized, stabilized, grade stainless steel used in marine application. 304L, 316L, and 317L. Don't forget those three numbers because they are commonly used, especially in areas where you need fabricate welding those materials. Select 316, 304, 317L. Those are special alloys. You can weld it, and those alloys avoid intergranular corrosion in the neighbor. And other common alloys for marine application is the 316. The content of molybdenum is in between 2 and 3%. The 409 is excellent for high temperatures. It's used in the fabrication of exhaust pipes, especially for diesel engines. And the 410 is for areas where the corrosive environment is not too high. For that reason, this is very common in marine application. I hope you enjoy this explanation about the series. We are going to use in the future the series 300, and we are going to refer, when we refer to the series 300, normally we refer to 304 and 316. And when you refer to the series 400 are the 409, the 410, remember the series 400 are magnetic. Thank you.